Okay, ladies and gentlemen, so you've got yourself some velocity data for the momentum extension, and here is how you deal with it. First things first, all of this up here, this is positive velocity, right? So that means your little G-force car was moving forward, right? All of this down below, that is negative velocity. And that means that your little G-force car was moving backwards. Because remember, velocity is both speed and direction. So this is the data from one car when it crashed into another. Okay, so this little car rolled down, it hit the other car, and then it rolled back up. Yeah, and so that's where this data comes from. All right, now I went into my Pocketlab notebook and I found the velocity for the highest velocity point there and the highest velocity point there, or I guess I should say lowest technically. So this one right here was 1.085 meters per second, and this one down here was negative 0.734 meters per second. Now, you had to weigh your Pocketlab car, and so let's just assume for the moment that the little G-force car that you were rolling there, let's assume the G-force car weighed 45.0 grams. All right? Now, in order to do a momentum calculation, you have to convert that into kilograms. So, in order to do that, you say how many kilograms is 45.0 grams divided by 1,000 grams per kilogram, because there's 1,000 grams in a kilogram. And so that is going to be 0.045 kilograms. And so that is the mass of your G-force car. All right? Now, momentum, of course, we use the abbreviation P. Momentum is mass times velocity. So the momentum here is going to be 0, let me do that slightly differently, 0.0450 kilograms multiplied by the velocity, 0.085 meters per second. So the momentum at the top is going to be 0.045 times, excuse me, 1.085, or 0.0488 kilogram meters per second. And that's the unit that velocity reads at. So that is a positive momentum because the car was moving forward. Now, I'm going to try that one more time. There we go. I keep messing that up. Perfect. All right. Now, the one on the bottom, this is positive because the car is moving forward. Okay. The one on the bottom is also P is equal to mv, of course. the car has the same mass. That didn't change. All that changed is that now it's going at negative 0.734 meters per second. So 0.045 times negative 0.734 is going to give me negative 0.0330 kilogram meters per second. In theory, momentum should be conserved, and so whatever it had in the beginning, it should have at the end going the other way. But of course, there's energy lost in the collision, etc., etc. That is what you'll be investigating during this laboratory. But this is how the calculations are done. Good luck, and if you have any questions,